Hello everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. In this series, we discussed about the theoretical fundamentals of artificial intelligence. Today, we are going to discuss about logic programming in artificial intelligence. So, in this topic, we are going to discuss interpretation of on classes in rule chaining. First, we see the introduction of logical programming. So it is a problem-solving approach based on formal logic where knowledge is represented using facts and rules instead of step-by-step instruction. At its core are Horn classes. Horn classes is a special type of logical expression. So that forms the basic of reasoning in rule-based system. Then rule chaining is the process. So it is the system applies inference rule either forward or backward chaining. So to derive from new knowledge. This method is widely used in artificial intelligence, expert systems and knowledge representation because it focuses on what needs to be achieved rather than how to achieve it. So we will see one by one. First we see the Horn classes. Now let us discuss one of the most important concept in logical programming, that is Horn class. So a Horn class is a type of logical statement that contains a disjunction of literals, but with a most one positive literal. This special form makes reasoning more efficient, which is why Horn classes from the foundation of logical programming, especially in language like Prolong. So it's a disjunction of literals. Next, there are three main types of Horn classes. One is a definite class, fact, and goal query. So these are all the types of Horn classes. We will see one by one. First one is we think of its role. For example, if we say head implies body, it means the head, it's a conclusion. It's true if the body conclusions are true. For instance, rain of X gives clouds of X and wet of X. So here the fact, this is the simple form with only one positive literal and no conditions. It just states something is true. For example, next we see the goal and query. So here this type has no positive literal. It represents a question we ask the system. For example, father of John and Mary means we are asking, is John the father of Mary? So in summary, facts gives us basic truths. Rules help us derive new knowledge from those truths, and queries allows us to ask questions and reasons with the given knowledge. So together they make Horn classes the building blocks of logical programming and automated reasoning. Next, let us talk about rule chaining, which is the reasoning process that makes use of Horn classes. Once we have facts and rules stored in the knowledge base, the system needs a method to apply these rules step by step to arrive at conclusions. This process is what we call rule chaining. There are two main types of chaining. One is a forward chaining, another one is a backward chaining. So in forward chaining is called as a data driven chaining. That is start from facts and apply rules to infer conclusions. Next one is a backward chaining. It's a goal driven chaining. It starts from the query, that is called as a conclusion, and work backward to know facts. So this is called, these are the forward chaining and backward chaining. Next we see the example for forward chaining. Let us now see how forward chaining working with a simple example. We are given two rules. First one is a if A and B, then C. Next one is a if C, then D. So here the fact is A and B. We are also given the fact A and B are true. Now let's apply forward chaining step by step. First we look at rule 1. Since both A and B are true facts, The condition of rule 1 is satisfied. Therefore, we can infer the C is true. Next, we can take the new fact C and check rule 2. It says if C and D, since we know that C is true, we can infer the D is true. Since we know, so starting from the known fact A and B, and by applying the rules step by step, we are able to derive new knowledge. Finally, we conclude that D is true. So D is derived using the forward chaining. Next, we see the same problem, but this time using backward chaining. So our goal is to prove that D is true. We check the rule. The rules 2 says if C then D. So to prove D, we must check whether C is true. Next, rule 1 says if A and B then C. This means to prove C, we must prove that both A and B are true. Fortunately, A and B are already given a facts in the knowledge base. Since A and B are true, we can conclude that C is true. And because C is true, we can finally conclude that D is true. So in backward chaining, we started from the goal and worked backward to the rules until we reached known facts. So A and B, this goal-driven process helped us prove the D is indeed true. So D is derived using backward chaining. Next, we see what are the application of Horn classes in rule chaining. Now that we understand how Horn classes and rule chaining work, let us see some of their application in artificial intelligence. First one is a expert system. So these are AI system designed to mimic human experts in specific domain like medical diagnosis or troubleshooting. They use facts, rules and rule chaining to provide recommendation or solution. So next one is a natural language processing. It's a help in analyzing and understanding human language by representing grammar rule and applying inference to process queries or sentences. Next one is a automated theorem proving. So in mathematics and computer science, Horn classes are used in system that can automatically prove theorem by applying logical inference systematically. Next one is a knowledge representation. So knowledge representation is a way to represent knowledge as fact and rules, making it easier for AI system to reason and derive conclusions. The last one is a AI planning and reasoning. So in planning system, rule chaining is used to decide the sequence of action needed to achieve a goal, making it useful in robotics, decision making and problem solving tasks. So we come to the end of this section. I hope you enjoyed this section. Thank you.